Hello everyone, welcome to this video channel of the CRC 768. My name is Minjie Zou, and I am working as a research associate in the Institute of Automation and Information Systems. In this video, I will talk about the inconsistency management among heterogeneous models and interdisciplinary development. First, I will shortly introduce our motivation for working on this topic. Nowadays, competitive global economy requires the innovation process to involve a variety of stakeholders from different disciplines. Diverse teams from managerial to technical levels need to collaborate in order to address high-level vision of the systems as well as detailed functionalities and interactions between individual aspects in the system. Specific concerns are addressed by various models like business models, product models, mechatronic models, and planning models. However, the consistency of models is limited due to lack of communication between stakeholders and interdisciplinary understandings. Therefore, it is crucial to identify and handle inconsistencies among heterogeneous models throughout the whole product development lifecycle. Next, I'd like to show you some concrete examples of inconsistencies in an e-bike sharing system. Developing such a system requires interdisciplinary efforts. The group of society technology investigates the needs in society from potential users. The group of information system tackles software parts of the e-bike like board computers and data clouds. Groups of product development and mechatronics engineering develop the frame, the electric engine, the battery system, and so on. The group of manufacturing planning models how the whole e-bike system can be manufactured in a real industrial setting. In one research scenario, it is found out that there are two types of e-bike users. The first type rides e-bikes for short urban shuttles, while another group ride e-bikes for very long trips. However, the current e-bike batteries cannot support such long trips completely. Therefore, from a business perspective, it is decided to provide one more type of e-bikes for longer ranges. Compared to the regular e-bikes, the most technical specifications of the new type remain the same, but the capacity of the battery should be increased. It also means to have a larger physical size of the battery. For manufacturing such e-bikes, the gripper and conveyors used in assembly must support the size of the batteries. In this scenario, some inconsistencies may occur. As the first example, the battery capacity may not be able to meet the requirements on the bike range. Secondly, the battery size may not be feasible for a desired power capacity. Thirdly, the desired battery size may not fit with the size of the assembly grippers. Last but not least, the data services in the cloud may not be allowed by the adopted sensor types or violate country-specific privacy laws. Managing inconsistencies consists of two parts: identification and resolution. To identify inconsistencies, measures should be taken in 5 phases. In the first phase, it is necessary to trace the information flow among different development teams. Based on the information flow, we could be able to identify related models and how they are related to each other. After that, dependencies among related models can be detected. However, because the models are from heterogeneous domains and teams, they come in different languages and forms. Therefore, a general formal form is needed to consolidate and compare the information. This is done in the fourth phase. Finally, in the last phase, dependent information in the same form can be analyzed with regard to some rationale and user-defined rules. To this end, inconsistencies can be exposed. After inconsistencies are identified, we should first analyze them and resolve them in an optimal way. The resolution process is shown on the right side. Results from the identification process, like related models, dependencies among models, and identified inconsistencies, are further utilized and fed into a knowledge base. It is also necessary to define some fixing rules to generate all kinds of alternative resolutions for individual inconsistencies. It is worth mentioning here that individual resolutions are not always reliable. They may even increase the number of total inconsistencies, because some information usually overlaps among models. The modification in one model will probably lead to new inconsistencies in other models. This is regarded as ripple effects. In order to avoid such side effects, all the possible resolutions for inconsistencies should be checked with related information in other models. Furthermore, an optimized resolution plan should be made in order to cover the most inconsistencies while keeping changes in models to a minimum. Thank you for watching this video. If you have any questions, please feel free to contact us. If you like this video, please subscribe to our channel. Thank you.